Now this recording is going to look at the control of cardiac output, but it's the second part. The first part we did an introduction to the cardiac output, looked at the autonomic nervous system and other factors that could affect heart rate. This one's going to address the factors that affect stroke volume. So as a reminder again, cardiac output is equal to heart rate times stroke volume. So cardiac output is a rate, the volume of blood that's being ejected from the heart every minute. Now we're going to look at factors that affect stroke volume. Now if you remember, an equation for stroke volume is end diastolic volume minus end systolic volume. So if you just look at it as a concept, and I know everybody hates math, but you gotta have to do conceptual math, is according to this equation, if I affect end diastolic volume or end systolic volume, I could affect stroke volume. So we're going to be looking at first things that affect end diastolic volume and how it affects stroke volume, and then look at factors that affect end systolic volume and therefore affect stroke volume. So if you look at this, you have some of it filled in right now, but we're going to look at things that affect end diastolic volume. So if you look over here, let's look at this one here. Actually, we'll start here. If you notice, if I increase end diastolic volume, that would increase stroke volume. Just plug in some numbers, that makes sense. So if my stroke volume was, if my end diastolic volume was, say, 100 mils, we'll just make it easier, and my stroke, or my end systolic volume was, say, 50, my stroke volume would be 50 mils. But if I increase this to 120, then my stroke volume would be 70 mils. Okay, so that makes sense. So if I increase end diastolic volume, stroke volume goes up. If I decrease it, stroke volume will go down. So what things affect your end diastolic volume? So let's look at filling time. So filling time represents the amount of time that you spent, the heart spent filling up. How much time did it spend in diastole? So when we went over cardiac cycle, we looked at the different phases that are part of diastole. We said under resting conditions, you spend about 2/3 of your cardiac cycle in diastole, but when your heart rate goes up, you start spending less and less time in diastole, but it does not going to be 2/3 again in diastole. You start losing more time in diastole, so you have less time filling up. So if your heart rate goes up, what can happen is your filling time will go down, which you see here, which would decrease your end diastolic volume. If you increase filling time because your heart rate's slower, that would increase end diastolic volume. So with filling time, ultimately, it had to do with how much time you spent in diastole, which would be related to your heart rate. So again, want to mention to you what I had mentioned in the previous recordings, is there's kind of crossover between heart rate and stroke volume. So you'll notice here heart rate's affecting your filling time, which affects your end diastolic volume. Now, other thing that will affect your end diastolic volume, which we refer to as preload, is venous return, that volume of blood that's returning to the heart from the venous system. So you'll notice on here we have an increased venous return leads to an increase in end diastolic volume. You got more blood coming back in there. A decreased venous return leads to a decrease in diastolic volume. But I also want to show you something related to this venous return and its effects on cardiac output. So there's a thing called STARLING'S law of the heart, or it's referred to as Frank Starling, and I put the hyphen because it's two different people, Frank and Starling. What the Starling's law of the heart shows the relationship between end diastolic volume and stroke volume. So if you notice the curve is as end systolic volume increases, stroke volume goes up. Two limits. I mean, it has its limitations. Is The reason for this is as more blood goes into the heart, it stretches those muscle cells. And as it stretches it, it actually allows more cross bridge formation. And when you have a more ability for cross bridge formation, you'll get a much more forceful contraction. A much more forceful contraction will lead to an increase in stroke volume. So they call this some people refer to as the Starling's law of the heart, is the more in, more out principle. The more blood coming in, the more blood going out. And it's because of an increase in contractility. So more blood comes in, more forceful contraction, more blood goes out. Now, question here you see is what happens to end systolic volume with a more forceful contraction? That should actually decrease because you're forcing more blood out of the heart, which would lead to an increase in cardiac output. Now, if we go back here again, so we'll see is two things, there are two major things that affect the end diastolic volume: venous return and your filling time. So the changes in end diastolic volume will affect your stroke volume. Now let's look at things that affect end systolic volume. So if you look down here, again, stroke volume is equal to end diastolic volume minus end systolic volume. If I increase the end systolic volume, that would lead to a decrease in stroke volume. So again, let's just use some numbers. 100 minus 50, that was 50. 100 minus 60, that's 40. So that means if my end systolic volume goes up, I'm leaving more blood in the heart. It's not going out. So that's going to decrease your stroke volume. If you decrease your end systolic volume, that will increase your stroke volume. So let's look at some factors that affect it. So we're going to go backwards. Obviously, contractility. We kind of previously discussed contractility using that Frank Starling as an example. But if we have an increased contractility, you're going to leave less blood behind. That would decrease your end systolic volume. If you decrease cardiac contractility, that would increase end systolic volume. Now, what factors can affect contractility? So you see all these things up here. Is contractility can increase because of sympathetic stimulation, which was addressed in the previous recording. Now you'll notice I have decreased by parasympathetic, and I said previously, but the textbook has, well, it's decreased by parasympathetic. I tend to kind of shy away from that because of the lack of innervation of the ventricles by the vagus nerve. But technically, because if you have decreased contractility of the atrial muscle, which is innervated by the vagus, that could lead to less blood going into the ventricle. So I'll put like question mark. It's not a huge thing. I rather say increase sympathetics or decrease sympathetics. That would be things that would affect contractility. Other thing is we had mentioned is hormones. I had mentioned epinephrine and norepinephrine from the adrenal medulla, your thyroid metabolic hormones, T3 and T4. Here's a new one, glucagon. We're like, glucagon, that's released by the alpha cells in the pancreas, and its main thing was affecting blood glucose levels. Its job was to increase blood glucose levels. How the heck does it affect cardiac contractility? Well, it actually does via its effects on glucose metabolism. And I'm without having to go into huge amount of biochemistry, is because of its role on glucose metabolism. Glucose is an important energy source, which is going to be needed for contraction and all that fun stuff. We'll just leave it like that. Is glucagon, believe it or not, does have a positive inotropic effect on the heart. And so, it's still used in hospitals under emergency situations when they need to increase the contractility of the heart. So I'm just going to leave it at that. But glucagon, it does have a positive inotropic effect on the heart. Now, if we look at these other things, like what is this with afterload? So remember, the ventricle, say left ventricle is contracting. It has to generate enough pressure to exceed the pressure out in the aorta to get the semilunar valve open. If that pressure out in the aorta is higher, the ventricle is going to have to work harder to get higher and higher pressure to open up that valve. What could happen is if you spend too much time in isovolumic contraction, which is when that would be happening, generating that pressure to open up the valve, is it will not necessarily allow you more time during ejection. And so you can end up with more blood left behind, an increase in end systolic volume. So if you have an increase in afterload, which is that pressure load, that could increase end systolic volume, which would lead to a decrease in stroke volume, and then vice versa. So I'm going to look here. So just showing you a graph that shows your relationship between afterload and stroke volume. So here's a normal heart. Yes, if you increase afterload, stroke volume is going down. But look if the heart's already malfunctioning, not working right, even greater decrease in stroke volume. So if the heart's in failure, you do not want to expose it to a higher and higher afterload. And during lecture, we'll address some of the things that could affect afterload that you, as a normal person, could do that would increase afterload in the heart. But we're not going to address this in this recording. Now, if we go back here, we're actually going to touch on it a little bit, is what are things that could affect the afterload? Well, afterload can be increased if you have vasoconstriction. If you have a lot of blood vessels constricting, that's going to provide an increased resistance to flow, and that could provide higher pressure in the aorta, which then leads to an increase in afterload, at least in regards to the left side of the heart. Then opposite, if you have vasodilation, that would result in a decrease in afterload. And I want you to put in your head is what would be the role of exercise or certain types of exercise in affecting these things here. Because that's something that I actually do want to discuss in class, is the role of certain types of exercise and its effects on afterload, and therefore affecting your cardiac output. So this is going to be the last bit of the recording that's going to address factors that affect cardiac or regulate cardiac output. During lecture, we'll address some abnormal conditions that can affect your cardiac output, things like valvular defects, certain medications, how they affect cardiac output.